Hey, we are live. Hello, everybody. It's me, Mikhail, and Alejandro with me today. Uh, we are going to talk about Kotlin 2.1. Hey, we had a release.
Hey,
Good stuff. Nice. So, everybody who are with us on the stream today, tell us where you're from. Tell us how you're excited about Kotlin 2.1 being released, and it's the first time we are doing this. It's the first time we are celebrating a release with a live stream right after the release. I must say it's kind of a rare situation when we planned the stream and the release happened the day before. So kudos to the engineering team for this one. So we didn't have to replan our stream this time. So what are we going to do today? We're gonna look at the language features, but not only. Let's quickly check what's in the release, and I'm going to bring up the slides on the stream. So Kotlin 2.1 language updates. But if you look at the what's new notes, there's much more. There are a lot of subsystems in Kotlin. Of course, you have heard of K2 compiler, you have heard of Kotlin multi-platform, Kotlin native, Kotlin WebAssembly, and so on. All these subsystems has gotten some interesting updates, but we are going to focus solely on the um, language features today. So, like, check out the release notes, check out this document in the documentation, the what's new in Kotlin 2.1.0. Probably a few things to highlight. First of all, Kotlin multi-platform comes with Swift expert support, like the basic one, and do I remember anything else? Like K2 compiler mode is in the IDE. You have to enable that to actually try something in your IDE with Kotlin 2.0 or 2.1. But let's take a look at the language features that we are going to talk today. Uh, there is a list, and we're gonna go through this list one by one. We're gonna look into the details and try to explain the design decisions and bring up some examples, maybe from some real life examples, like why this feature is useful. And if you agree or disagree with us, you know what to do. You have to paste the comment, write the comment in the chat, and we try to address the questions as they come. I'm going to monitor the chat, so no question is going to be left unanswered, I hope. And where can we start? We're gonna start one by one from the top. So, and the language design team who is with me today, Mikhail and Alejandro, are going to address your questions as well and explain some interesting details about those features. So the very first on the list that is not experimental but works out of the box when you install 2.1 or upgrade your projects to 2.1 is this opt-in requirements for subclasses. And it seems like a nice feature for the library authors to control the impact of the experimental APIs that you know that the consumers of the library might be using. So, Mikhail, maybe you can uncover the background for this feature and how did it happen that it made it into the language? Why?
yeah. So hello, everyone. I think we can provide a bit more context before going into the detail of this particular feature. So in general, we have these opt-in mechanics to mark parts of the API that are not completely safe to use. And in a nutshell, declarations with an opt-in annotation issue a warning or an error at the call side. And it might be useful as it's often the case that we are pretty sure about the major API shape of a library, and we would love to roll it out. but there are a few methods or classes that might still require some changes in the future. And normally what we do in such case, we would just mark the entire library as alpha or beta, but with opt-ins, we can add more granularity to it. And we can publish our library as table and then gradually stabilize opt-in declarations. And here with SubclassOptInRequired, we are addressing one specific case involving inheritance. And you probably know that we are pretty strict about inheritance in general, as our classes are final by default, because we want our users to be very conscious about making a class open. It's much harder to evolve such a class later. So that's part of the story is quite important for us. And here's the case. So there are scenarios when we are confident about the API of an abstract class, for instance. And in this case, it's absolutely fine to call it methods, to use it as a type, and so on. However, I, for example, as an API author, I might want to add another abstract method to it, which could break existing users who have implemented this class. So what this annotation is actually doing, it allows me to mark my class as stable for use, but it will issue a warning if one wants to inherit from it. So this way, my users are safer in terms of compatibility, because they can still use it and call methods and get all solve the issues. But at the same time, they will be warned if they want to inherit from such a class. And another case is it comes from real world imperfections. Usually there's a case when I want to seal my class for third-party implementations, but still have it open for internal use, because I want actually to rely on some internal contracts. I want to probably downcast it to use some internal methods and so on. So that's basically those two main use cases that we want to cover with this addition to the language.
I see. So I actually have this code in my IDE, and let me bring it up. And actually, before I bring it up, let me explain what people should be doing when trying to use Kotlin 2.0 and beyond. So if you go to the settings of the IDE and search for Kotlin, there's this languages and framework section for Kotlin, and you need to enable K2 mode. That actually requires restart when you enable or disable it. And that's for the reason that by default, it's not enabled. It's going to be enabled, I think, in the next IntelliJ release. Currently, it has been enabled by default in the AAP, but by default in the release version, it's not enabled. And to get support for all these new language features, you need support in the IDE for that as well. So K2 mode enables that, and you gotta enable it when you move to anything that is 2.0 and beyond, including 2.1, of course. So I have it enabled, and I have that example right here. Let me see. Yeah, the very same one in the slides. So you can actually find all the examples that we are showing in the GitHub repository that I have prepared for you. Let me show you that one as well. This is the place. It's my GitHub account. I think I'm going to transfer that repository under Kotlin as well later on, and we're gonna have that in the description for this stream as well on YouTube. So let's see this very example. Like if I don't specify this annotation on the user's code, it's gonna show me the error, right? Like it's the compilation error. The code is going to fail to compile, and I can control that using this severity level. It's either a warning or an error, so I can switch it to warning if I don't use the annotation. By the way, if I'm not using the annotation, what will happen then? If I'm not actually opting it in, the compiler will just tell me the warning, but the feature will be, the class will be working, the APIs will be working as intended, right?
Right, right. And also, if you have a method in this interface core library API, you can safely call it, and there will be no warnings at all. So the warning is issued only at the position of inheritance. And you have two options. You can either have this warning, you can either opt in for it, or you can actually propagate this warning for the next person who would love to inherit from my implementation interface.
And we have the IDE action for that as well, to include the opt-in annotation. So alt enter is your friend. Alt enter, select whatever you want to do, and maybe you don't want to handle it. Maybe you want to propagate it, right? If I want to propagate, what do I do then?
You'll have to mark it as unstable API annotation. So,
oh yeah, correct. So I'm gonna do it like this, right?
right. So
Perfect.
in this case, yeah, the next people who would love to inherit from my implementation interface will get this warning.
So you can just say it's not my problem now; it's your problem.
Right, right.
Perfect. So let's check the other feature that we have in the release, local break and continue in lambdas. That's an interesting feature. Like if you haven't encountered any problems, if you haven't written this kind of code that requires break and continue, then you feel it's like, why is it even in the release? But let's take a look at this one. That's an interesting one. So suppose we are like reading the files and we want to read the first line in the file, like for each file, and you're writing this extension function that is going to provide this functionality, and we're gonna iterate over the files in the list. So there's this file in and the receiver, that this receiver is now like an outer receiver because we are inside the lambda for the build list function, the lambda that is a parameter for the build list function, right? That is why we need to specify this receiver explicitly. Then well, we open the buffered reader. How else we gonna read the files? Like using the buffered reader, of course. And then check if the line is empty, and if the first line is empty, we just continue to the next line so that we could read it, so that we get the first non-empty line. And if the line is not empty, then we're gonna add it into the result and build a list, and then have the list of the first lines of all the files as a result, right? One interesting side note, how are you able to call a method that is checking for null if the value is null? That's a question to our audience. The language designers obviously know that, and I'm going to monitor if someone answers this question. But so let's dive into it a bit more in details. Alejandro, can you tell us something about it?
I mean, at this point, the point here, and I guess we'll show the changing example is that this is code that you may just kind of write. Like we have a lot of ways to iterate, but still for loops in the case of Kotlin have this nice thing that you can call continue and break to stop it, to maybe have something over. So I mean, it's still an kind of an important part of the language. As we will see, we want it to be very well supported, and that's actually why we are kind of expanding the power of break and continue.
Mm-hmm. So I have this code in the IDE. Actually, we'll retype it a little bit for everybody how this happens, and let's see how the code transforms when we actually write this kind of code. So we're gonna read the files first, and the completion, the AI completion is too good here. Immediately recognized my code because I have tried it before. I don't know if it has a memory or anyways. So that's the code we just seen on the slide.
Maybe the code was already written by the AI.
Maybe it's like a template code. We didn't know. So this is this code that was in the slide, and we are iterating. We are using this continue statement to continue the loop if the line is not empty. Someone is screaming that, my eyes. I guess it's about the light theme, but sorry, folks, we are old people. We need to see it well, and we need contrast on our screens. So that's the light theme. And well, did anyone guess how it's possible to call a function on something that is supposedly null? Are there any comments? Let me see quickly. Okay. And no one, I guess. But let's dive into the implementation, because it's defined on a nullable type, and there is also a contract that kind of contributes to this safecast, right?
Mm-hmm. Yeah,
I guess. And there is this null check. So and because it's a short circuit, well, there will be no null pointer exception if the value is actually null. So this way, I mean, I wanted to highlight this because it's so elegant in the language that we can do this kind of things and not write the null checks in the conventional way. Yeah.
No, exactly. Guys. You were actually talking about the smart casting, and you can see there in the below that the line has a smart cast. So actually, the compiler is clever enough to say if this is false, then line is not false. Sorry, line is not null, right? So it's I love this kind of small things.
Exactly. Smart casts are surprisingly useful feature, and I kind of started to appreciate it even more after the 2.0 release. But what's wrong with this code? We kind of can realize that the buffer treater should be closed and consumed correctly. So maybe we can ask the AI to rewrite it, because it already knew the code. Well, maybe it can fix its own mistakes. Rewrite this code to you, this code correctly with use function. Let's try that. Will it fix the problem or not? Oh, it did. But now we are using this use function with the lambda parameter, and as you can see, all the rest is the same. How come? Before 2.1, we couldn't call the continue function from a lambda, right?
Yeah, and that's kind of the exact what this feature is bringing, right? Like if you think of functions like use and you can add things like let, apply, with, run, you often think of them as kind of transparent, right? You this add some extra safety, but other than that, the idea is that you write your code in the same way. And before this release, in order to keep using continue, well, you couldn't just use continue, right? Because the use had a lambda is a function which takes a function, and this was creating like an extra scope that was breaking this. And in this version, well, this has kind of you can think of it as just making the whole lambda thing more transparent when they are inline. You can see it on the name of the feature, which is called like break and continue in inline lambdas in the compiler, and that kind of means that use is kind of transparent to this loop and iteration contract. So you can just use continue, and this continue will just refer to the, in this case, to the closer loop, which in this case is for. So it's like, now it works. Before it didn't. Now it works, and I think it's, I mean, to me this just gives you just another a simple way to refactor code. If you introduce any of those things, and before, like, literally doing this would require extracting your code into a function to use not block and return, or maybe actually rewriting your function altogether, whereas now you can just put use open braces and keep the code as it was before.
Yeah, and
there are
just
some. Mhm.
maybe just a small note on why we didn't add this feature earlier, because conceptually it's not a syntactical feature, but more rather an implementation detail of the compiler. So we actually had two paths previously. We could either make a few of our functions like repeat for each, and so for like function inline functions be closer like a for loop, so to allow continue and break inside them with the similar semantics as for loops have. Or what we did actually is that we decided to make continue and break transparent for for all inline functions like use and with and so on. And it looks like a better choice, because we see that now with functions with context functions are very popular nowadays, and the whole context style programming is just growing, and that's why we decided to take this route and decided to implement it in Kotlin nowadays.
Right. I can see some interesting questions in the chat, so maybe we can address them quickly. So this is an interesting one. Lambda must be crossing line. I'm not sure about how the reasoning goes here, but maybe they assume that Lambda must be crossing line for this feature to work. And
you can go into the actual, like, if you could navigate to the implementation of use, that you can see there that isn't marked as cross inline or anything like that. I mean, the only requirement is the function use must be inline, because that's what kind of inlines, you can think of it inside the body of the function. That's what allows us to actually know where the continue goes. Because if you have a function which is not inline, think of async, then this doesn't really have a very well-defined behavior. Like, okay, you have an async thing, and then you are continuing on a for loop that's very. So this is really for inline functions where we can really know what's going on. But other than that, there is no further. You can see there the block is not marked as cross inline or anything.
Mm-hmm. So, like, the influx of question is happening right now. So, this one, I assume this only works with in unit
Again, no,
returning lambda.
that's
That's not true.
you can see it. It's not. It's just you can have anything. So in this case, maybe what was so we have changed kind of the whole block of inside the for into this use, but it does not have to be the case. We could have code before and afterwards the use. That's completely fine. So it doesn't have to just, so the lambda doesn't have to take over the whole loop. It can just only take over a part, and that would be fine too.
Yeah, and
like we can
additional
have
question by this, no, not by the same person, but like, so about repeat function. I haven't tried it. Like, repeat 5, what will happen there? Like, if it is less than, no, greater than 3, then what could I do there?
Yeah,
you
so
cannot continue.
You cannot use continue, but it was somewhat our idea previously that we might allow using continue inside repeat or for each inline functions to make them closer to for loops. But we decided, and that's why basically this was one of the main reasons why this feature was prohibited previously. And we decided that it's not a good idea afterwards, and it's better to allow continue and break inside for loops.
Okay, so it's only for native loops. One other question that is unrelated to this specific feature, but since we already flashed a few times the implementation of the internal library and we had contracts mentioned, maybe we can unfold or like reveal some information about this, no?
Right. So this is one of the features that we also very alike, and we know that it's very not complicated, but it actually allows to do to build safe DSLs and to write safer functions. But it also means that the feature is very powerful. And one of the main reasons that stops us, but there are two main reasons that stops us from making it stable. The first reason is syntax. So if you take a look, for example, if you can navigate to the use function, yes, you can see that right now we use this contract DSL, and it's placed on the first line of the function body. And we are not sure that it's the best thing, because contract actually, it affects your signature. So it tells what tells more about the behavior at the call site. So it probably should be located somewhere closer to the signature and not in the body of the function. So that's the first thing that we are working on right now. So it's syntax for contracts. And the second thing is that we want to verify the most popular contracts. It's impossible to do it in general, so to verify the contract, but we definitely want to provide safer experience for people who would love to use contracts. So these two things that we are actually working on and hope to provide, especially about the syntax part. This is something that we will provide relatively soon. And about the verification with the K2 release, starting from 2.0, we can verify a few contracts, and we plan to add verification to more of them.
Well, but there are some suggestions already about this. Like if we have context syntax, which by the way is it final? I mean, it's an experimental feature still. Like
right, it's an experimental.
Might not be final. Yeah. So there's the answer to this question, I guess. Like, yes, we have the syntax, but it's experimental. Therefore, we wouldn't commit immediately, I think.
Right.
All right, so that's this interesting feature. It's exciting to see that all the folks in the chat are excited about. So let's move on.
Maybe Anton, I think
yeah.
you haven't shown it, but in order to use this feature in particular, you need to enable some flag in your build file. So maybe it's good to show this to the people.
Exactly. So there are two options to enable that. Either you configure it using this compiler options block in your build Gradle DSL, or using this, where is it? Non-local break and continue option. That's the one. Let me zoom in for those who are looking from watching the stream from the mobile. Or there is another DSL, not stringly typed, the language feature and break continue in inline lambdas dot name. That's the way I configure it for my project. Again, there will be a link on GitHub project, on this very GitHub project, so you could download and experiment and try those features out. Just don't forget to enable K2 mode in your IDE. And well, we can experiment. If I switch off this feature and recompile, reimport, let's see what happens then. Then this feature, this continue statement is highlighted, and there is a warning by the IDE that this break continue in inline lambdas is only available since language version 2.2. So it's not a feature that is enabled by default. Okay, so let's enable it back and re-import the project. And meanwhile, let's go to the slides again and check out the next feature, which is a multi-dollar interpolation. On my mind, I think this has been one of the most voted tickets, or one of the most discussed ones for, is it 8 years old, or how many years old it is?
I think it's even older, yeah.
Maybe it is even older. But there has been so many discussions and so many creative workarounds for this problem. So let's take a look at this. So that's a very basic example. You have a string template, and there is an ID that you want to be rendered as like $ID in the string, but because how interpolation works in string templates in Kotlin, the ID shows you an error because there is no ID variable in defined prior to this string, and well, that's the compiler error. And what could we do about this, and what kind of workarounds there are? And the primary workaround that was suggested was to use this interesting sequence, like a dollar and then this curly braces block and then another dollar inside. And there are some more creative workarounds for this. We're gonna see in a moment. But well, this is ugly when you have to do a lot of those workarounds in the same string, in the same template. I think I have seen some issues even related to Spring annotations and how you define values in the annotation. So when you needed this interesting feature inside the annotation value when using Spring, it looked really ugly. But well, it's not something you do all the time, but sometimes it's like a corner case. And but now we can use this multi-dollar interpolation, which is also like, is it experimental? What kind of status for this feature is?
It's also an experimental feature right now.
Yeah, so you need to enable that using this -x multi-dollar interpolation key, or as I showed a moment ago, using the DSL, the predefined values in the DSL. And what else you can do? Well, yeah, you can then this sequence, this $$ sequence becomes like a control sequence. The interpolations symbol in the string template. Sorry, spring, string, and swing are very similar. Sometimes mixing them up. But the funny part is that you can come up with very long sequences, and as Mikhail told me right before the stream, we have actually tests in the compiler for this. But an interesting post that I have seen just yesterday after the release announcement was that Tor from the Android team posted this one, that he's very excited about this feature, and this is why. And in the post, it's not visible, like how they actually work around this feature before 2.1. But if you go to the link, there is the source code for Android, and this is how they do it. They kind of use like a different ASCII symbol in the source code, and then in post-processing replace those dollars like to the correct ones. That's a creative way of working around the problem. Yeah, there are some interesting comments like so many dollars. Nice.
Yeah.
So do we have any implications of this feature? Like what's up there? Like, is it going to, like, do you anticipate this feature to stay as is? Why did we release it just as experimental under opt-in, but not in a stable state?
Yeah, so there are a few reasons for it. First of all, is that we want to we need a bit more time to stabilize, for example, all our IDE support inside strings. And the other one is that we want to get more feedback and hands-on experience from people. So we would love them to try the feature and see whether it works for their cases, and it's not. Because like I think that we can talk a lot about strings, and because it's one of the core concepts. Yeah, you can try to enable it and add it to code.
It's a good way to try.
Right. So yeah, strings, it's a topic for several lectures, and if you take a look at a few languages, you can find that there are a lot of types of strings there. So there are Unicode strings, raw strings, escape strings, template or interpolated strings, binary strings, and sometimes even immutable symbols or atoms. So as in Ruby or Erlang. So let me check the question. They start to think it crowded, expanding, definition, more features with dollar. Start. I'm not sure whether it's. I wouldn't say that it's going to keep expanding because here we want to cover one specific case. Because again, in Kotlin, so there are a lot of types of strings that we can find, and languages normally have to pick only a few of strings that you want to add to the language because it's a core concept. And for example, if you check your application or its memory layout, you'll probably find out that strings occupy most of your memory because they're essential in your application. And that means that, and usually depending on the actual domain where we want to operate, we pick these or that strings to our language. And in Kotlin, we have those escaped strings where you can use \n as a new line, and raw strings which you can use for multi-line strings, and where \n is just two symbols. But also we want to combine multi-line strings with interpolated ones. So it's possible to use $sign to refer to variables and to interpolate them there. That's a nice advantage. But of course, as it usually happens with an advantage, you have one more disadvantage. And in this case, you can interpolate, but $, is a special symbol in our multi-line strings. And during our investigation of interpolated strings in different languages, we found that C# has an interesting case with they also have this feature where you can put $2 in front of your string and to give it a special meaning. And just immediately clicked for us because in Kotlin we use $ for interpolation, and we could say that if you put $2 in front of your string, it means $2 are going to be used for interpolation, and $ can be used just as a symbol. And it's nice and solution. And we don't expect people to put a lot of dollars in front of their strings because normally you don't want to use multiple dollars and then an identifier in your string.
Yeah, it's probably important to understand that this is a solution for an ugly workaround for a very special case. It's not something that you would normally see in the source code, I guess.
But speaking of the domain, you showed a nice example with JSON schema, and because it's actually one of our domains. We know that we work with JSONs a lot, and a lot of our applications are just JSONs with modern UI. So that's why this case is quite important for us, and we want to make it. We want to make our language convenient to use here.
Yeah, there's another question. Not this one. Sorry, but this one, but because the chat jumps a little bit. So people immediately would start thinking of what else they could do and what other powerful constructs could this feature support. In my mind, string interpolation could be just about templating, but maybe you have some other ideas about this?
Yeah, so that's we investigated this story and we looking around, and mostly we see that the main use case for interpolation is it's for templating and to refer to variables. There is definitely a case for SQL, and in general we can turn data into the code. For example, if you have custom interpolation, we can even build collection literals to give special meaning for symbols inside your string, but it might be slightly over the top. And SQL case, it actually can be solved with modern libraries and frameworks, which have all the linters, the dedicated DSL, which is also going to be type safe. So we are still looking, and we might add a custom string interpolation to Kotlin one day, but it's not on our shortlist.
All right. Well, Java added this, and they took this feature out even
And-
from the experimental state.
Exactly, and it actually wasn't the first case when Java decided to take string interpolation mechanism back. They also had a design similar to Kotlin ones, but also people weren't that happy.
Mhm. All right, let's take a look at the other feature that we have in the release, the guard conditions in the when with subject expressions. And well, this is a controversial one. We already had a stream, I guess, a couple of weeks ago with Alejandro discussing this in very detail, but we can shortly go over this again. And we
Yeah,
have
I'm
prepared an
sorry.
example.
I'm sorry for my obsession with when expressions. Like this is
So maybe it would be even better that if we switch to your screen, Alejandro. Would you be able to show stuff? Like
yeah,
I
yeah.
can, yeah, I will bring it
I
up
have
now.
it. I have it here, I think, so I can just show the code. Let me show this one.
Mm-hmm.
Yeah. Uh, yeah. So what guards allow you to do? Uh, so maybe to give a bit more context, right now, Kotlin has two, let's say, two ways to use when. You can just have when with no subject, with nothing here, and then well, you just have a bunch of Boolean expressions. So in that sense, it's like a nicer way to write a bunch of if, else, if, else, if. Uh, but I think what most people use this for is to have a subject, something they want to check a few conditions on. Like, for example, in this case, we're trying to render the status of an application, and I'm showing here it with just strings, but you can imagine this being maybe like a composed application where, depending on the status, you want to show uh, a label or a progress bar or something like this. So just don't take it as just this a small line, because when we always have a small pieces of code, it looks like we could write it in four different ways. Yeah. Uh, so up to now, the this when allow you to check a few small things. You can check against a constant or an object, like here. So I have here my object loading. So if my status is loading, then I'm going to check this. And I could also have this is, which check if this is of a particular class, right? So I have other two cases here. Oh, my ID is going slow for some reason. I don't know why. Hmm. Yeah, now it's going. Yeah, so we have here the other two cases, okay, and error. Uh, but sometimes we want to like have a small side conditions on top of that. So what we find is that allowing all of this is sometimes very limiting, and forces you to write your code in a different way. So if, for example, we consider, as I was saying, rendering the status uh, in an application, in a I don't know, mobile device, you usually want to say, well, if I have some data, I want to show it, but if I don't have any data, you often want to show like a message which says no data received or no user, or some special case, right? And we could, of course, nest it inside the OK, but with guards, you can just essentially declare this is a special case in your application and say, look, go into this branch if the status is okay, but actually also this condition is true. And this condition could refer to anything. In most of the cases, what we expect that this condition will actually refer to something about the subject. Uh, so it's just a way to improve what we have for when to add these small side conditions to declare some cases, and you can essentially use it for In many other cases, like for example, here, if we have errors, we may want to check them directly, whether we have a connection or an authentication. To be clear, like this is an example code. It doesn't have to be this way. And in some cases, for example, in this error, maybe it makes more sense for you to actually have is a status error and then have a nested if, because you want to treat all the errors equally. What the kind of code that guards try to focus on is for what I'm showing here, for example, with the no data. You have a special case which in a logical sense is at the same level as the rest, right? So you can say, oh, what are my statuses? It's loading. I have data but it's empty. I have data but it's not empty, or I have an error. Those are logically the cases. So I can now reflect my logical thinking by using these guards, even if my logical thinking doesn't correspond directly to the types, right? So we can do this if we have types, but yeah. Yeah, so that's kind of guards. Maybe for the I see there is a question like using the syntax will check that the else is not required, and yeah, it will actually check that the else is not required. Right now, what you need to do is to cover all the cases without guards at some point. So I have an else there, and I know it's an unknown problem. I could also write is a status dot error, and the compiler will know that I've covered every case because I have the loading, I have an OK without a guard, and I have a status error without a guard. The compiler is not clever enough to know that if you have checked all the errors and then all the problems inside the errors, this is exhaustive. It's not that clever. But this doesn't mean that so in most of the cases, if you just cover all the cases without guards, that will be more than enough for the compiler to know.
Right. There is another question. I think, well, it will be helpful for people to understand the difference and how to use the logical ands in this kind of situations.
Yeah. So there is so actually that's can so for a long time, like why the syntax is what it is. You can check the key. I can give a brief summary, but like one way people have been writing this, and that's actually what we have got inspiration for, is that you could say, well, what I can do is I can like take my status. Sorry, I don't know why my so you can go and say, well, sorry about this. I don't know why it's going so slow. So you can say status equals, and then status, 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 status.
A lot of
And
repetition.
yeah, a lot of repetition for a status, kind of. And then you would use an and here, right? Because that's just
A logical expression.
a logical expression. You actually lose by doing this. You lose already something. Like for example, if exhaustiveness check is not available here because, well, we don't know what the subject is, right? So what are we gonna say check exhaustiveness upon? We don't know. So for the compiler, all these things are now unrelated because, well, they happen to talk about status, but they could talk about something different, right? There is nothing now forbidding me to say 1 greater than 2 in one branch. Then you can use that you're using and yeah. So some when we were showing this and we were discussing, it's just like we first try to use and like, well, let's make it kind of close to this. This actually bring some problems, and the problems are kind of technical in the sense that it mostly depends on how the language is parsed. But let me try to summarize this. So the first thing is that this and was being a bit weird when you have ors. So if you had like is a status okay and then something with or, this was kind of counterintuitive because the and will take precedence, and usually the or takes precedence. So when we had a design where we actually forbid using or directly on the guard. You have to use parentheses to make this clear. That could make it work. But kind of the name of the coffee is that actually you can use and in when with subject if you are matching against a boolean, because as opposed to other languages where the thing you have to have in the when with branches must be some kind of a pattern, a small subset of the language. In Kotlin, in the branch of a when, you can have anything, and that means also another when. So you have a corner case, and you can check carefully if you want in the description of this feature in the design document what the corner case is, where you actually cannot decide, is this a guard or is this matching a boolean against something which happens to be an and. So the compiler cannot decide about this. So that means that we had to introduce something different. And you can see that I think every language is kind of discovering that this is a problem. Like if you check Java, which also has guards, they use when, and in a previous version they used to have and. And if you look at the very bottom of their design document for guards, you will find a sentence says, we used to have an and, but due to problems with Boolean expressions, we changed to where. So essentially the same. We discovered the same problem. So we decided that if is a nice keyword. And the reason why I personally like if, you you can agree with me, is that this allows to actually introduce here. So if I go back to my previous thing, which I could maybe do, it will take some time because I don't know why this thing is going slow today. Never mind, maybe that's we can actually write else if. So the guard on the if doesn't have to have is or something. You can just write here else if, and maybe you have here some condition. I don't know.
Some other range.
And maybe you want to check something which doesn't have to do with the status, but maybe you want to check some configuration where you want to say, oh, if I want to show this kind of errors in this way, you can check this, and this else if kind of reads nicely, right? So if we chose another keyword where when, then it won't read as nicely. This of course is kind of super up to discussion, but these are kind of maybe the summary of this is using an and is not possible because, well, we will have to change how the language is parsed, and we cannot do this without breaking compatibility. So we had to use a keyword, and given a range choice of keywords, we decided to use if because, well, we like that you can write else if, and it kind of reminds you very much about this being a Boolean condition, right? Because that's what if gives you, right? A keyword like when doesn't have the same meaning. It's not a Boolean condition. So yeah, that's how we got there.
Okay. Yeah, Michael, you wanted to say something.
Just a small note here that we might, I'm not saying that we will, but we might expand guards to more use cases, and if just fits better than an operation, because we can imagine, I'm not going to into detail, but we can imagine guards in more use cases across the language, and if fits way better than an end.
Yeah, and in the ID, if you like, we expect you, or we predict that you still will be typing and the ID would help you to resolve those issues. Like if you are used to using our normal standard workflows with Alt Enter, then there is an intention in the new version of the ID coming that replaces the logical and with an if keyword. Just a quick fix. I wanted to bring up this screenshot actually from our sources that the guards are being used now like everywhere almost, like in the ID sources. And this is the source code from the Kotlin IDE plugin, I suppose.
Yeah, from IntelliJ IDEA. monorepo. Yeah,
exactly. Community edition plugins, Kotlin refactoring. So there's a lot of interesting use cases, and I checked. There's so many migrations now. So it seems to be that the one expression is just all around the place, and now we are migrating like to when with subject just almost everywhere. Okay, and the last feature, the last language feature update is actually not this one, sorry, but the other one, which is very much related, I guess, to the subject we just discussed about. And I guess I could bring up Alejandro's screen back again for this specific feature, because he prepared an example. Like when I first read about it myself, like my impression was that, hey, but we already have this feature, like exhaustiveness check on the sealed classes. Why are we doing something else? Like, what's new about it? And then I just missed the point that it's about generics, and it's actually not so obvious that you can write this kind of code. Like it wasn't in my mind, like from the very beginning, that I can use sealed classes in combination with generics. Like let's unfold it a little bit.
So I've kind of separate this into parts. So I will show you what the feature does, and then I want to show you, as you said, because Anton, that this is code that doesn't come so often, like a pattern where this code sometimes appears, and because actually this feature maybe does not affect a lot of code, but affects a lot the Kotlin compiler code, because this kind of reference I'm showing here is actually there's something very similar inside the compiler code. So we actually gain a lot by doing this. But let me show. So here the idea is that I have some kind of reference to a T, and this, you can imagine that that's a way to have things like, well, I have an ID, and when I call get, I will get something from the database. Like that's the general idea, right? And completely separate from this, I have here a bunch of classes which are form a sealed hierarchy in the case of farm animals. So I'm assuming that it's you only have cattle or sheep in your farm. I don't know. That was the example I came up with, and then here you want to have this function which works on any reference, and this reference is of some T, which is a subclass of farm animal. And very interesting here, it's not actually the case that you can always change this into reference of farm animal, because this reference thing doesn't have a variance annotation. So it is not the case that the reference to a sheep is a subtype of reference to a farm animal. So this case, the fact that I'm adding a generic with this upper bound on it actually is required for some usages. So, what I have here is that I have an animal. I get the animal, right? Then I will get some nullable animal. And logically, what we see is that this animal has some type T, which is bounded by farm animal, and it's potentially nullable. So if you cover the cases of null and the two possible cases of the sealed class, cattle and sheep, well, we are covering all the cases, right? But it used to be before 2.1 that the compiler was not powerful enough to understand that this is actually an exhaustive check. The else was needed here, and the reason for this is that if you look at the type of animal, the type of animal is actually T question mark. So given that this T is just kind of an unknown type parameter, this reasoning was not possible before. Now, because of the improvement, it can actually say, oh, wait, but this T has actually a bound. So I know that in the worst case, this thing is going to be a farm animal. So covering cattle and sheep is going to be enough. So this is essentially the change. We make exhaustiveness checking a bit more powerful. By the way, I like that you can actually introduce this gives milk here is an if. So it's another example of a gar. So That's actually the example I like to show, because to say when the and feels not natural sometimes, but actually if you try to write code and then the first thing you do is if, like pushing the if inside the guard feels to me a bit intuitive. But anyway, going back to the example, what's an example where you may want to use something like this? So let me show you a small example, and that's maybe a bit contrived. Uh, uh, by the way, there was a comment saying that you can make reference out, and yes, in this case, I guess you can make reference have an out variant, and this will also solve the problem. But sometimes you cannot do this, right? And that's the point here. That before this would work if the variance was declared uh, in the
But it's
definition of
just,
reference. But now it also works if your variance is defined in the function itself. So we are expanded
still
what we can reason
sometimes,
about it.
yeah, still sometimes you want to actually have two T's. For example, you want to use T in your receiver, and for example, you want to use T in your return type, and you want to be sure that it's the same types. It's not they're not different. So in this case, you cannot use just covariant types and use the base type of a sealed hierarchy.
Mm.
So going back to an example where having these T's sometimes help is that, well, imagine here I have again another sealed hierarchy. All of this is about reasoning about sealed hierarchy, so that's why it's popping everywhere. You can be success or failure, but in this case, I'm having also some kind of warning. You can imagine that that's like the compiler can compile your code, give you an error, but also has some side warnings. And then we have a function which adds a warning. So I'm implementing it here. You can essentially, well, you can read the code, it's just adding the warning there. But you have a problem here, because if I have now something which is a success and I add a warning, you lose some information because the result type of add warning one is always result. So the connection that this result is again a success is somehow lost. So one way you can model this is by saying, well, actually, when I have a warning, when I have the warning, you give me a T, and I give you back the same T. And then this T is bounded by result. And unfortunately, we need to add a jet cast here. But still, the code is safe because we are just we know what we are doing in this case. Uh, but what you can see is that if I now call add warning 2 on my original result, which is a success, the compiler actually knows that result 2 is still of success type. So this kind of pattern allows me to have to keep some of this information, even though I'm using this kind of style where I pattern match on the thing. So that's an example. There are more cases where this exhaustiveness just improvement rate pops up and you kind of maybe don't expect. But for me, this is a pattern I see very often, and this will just be improved by this case.
Yeah, and just a small note on this unchecked cast. This is a feature that we are also working on, which is called GADTs, or generic algebraic data types. You may check out the presentation from the previous Kotlin Conf. So yeah, exactly. So that's this is something that we would love to eliminate, because unchecked casts can be dangerous and you should avoid them. And in many cases, we actually can prove that they are unnecessary; they're not needed there.
Stay tuned.
Just to maybe clarify why this is hard is because we know that the thing is always a T, but the T is different in every branch. So we need to improve the compiler to have this reasoning in which it's not about the whole result of when, but actually about taking each branch separately, and that's a big story in its own.
Okay. We have one last thing left to cover that we have prepared for you. So let me add my screen to the stage. JSpecify. JSpecify comes actually from Java ecosystem. It's not really a language update here, kind of, but it's very, very much related to what Kotlin does, right? Because Kotlin is a part of JVM ecosystem. And JSpecify had a release, 1.0 release in August. And we know that Spring Framework has migrated to JSpecify annotations now. And well, specifically, we probably need to explain what JSpecify is for those who don't know, right, Mikhail?
Yeah, I think we can do it pretty quickly. So we actually have a lot of non-null annotations that you can use to mark your Java API, so that external tools, for example, IntelliJ IDEA, Eclipse, or some known linters, will use information and will either add checks that if you want to call them without additional nullability check, and so on. So for example, I can mark that here my method foo, it returns only non-nullable things, and I can be safe, and I don't have to add extra checks at every call site. And the same, I can mark my bar with that it returns actually a nullable string, and I also can mark my parameters and so on. And we actually had those annotations for many years, and the problem is that there are like dozens of such annotations. We have our own JetBrains annotations, we have Eclipse again annotations, we have Android annotations, and many other. And now people decided that we have to stop this, and we need to have some consensus on these annotations, and because they're slightly different in terms of semantics, in terms of what we can apply as a default, and whether if I have a mix of annotations, how they actually work with generics, and so on, so on. And now we have this, it looks like we finally got to this agreement and with JSpecify. We also, JetBrains is also part of this group, and because we have to represent Kotlin, and it should work with Kotlin pretty well without any quirks. And yeah, so starting from Kotlin 2.1, we are going to treat nullable JSpecify annotations strictly, which means that if you have your Java API annotates those annotations, then we'll treat those types not as flexible, but actually as proper Kotlin types, non-nullable or nullable ones.
Nice.
So yeah, if you have Java code, go forward and annotate your code, because it's going to be safer for Java, and it's be easier to write Kotlin code if you have to call Java methods.
There's a question in the chat, or rather a comment about treating all the Java types as nullables by default. But if you recall, this was the behavior in the beginning. And to be honest, it was very impractical. All the code was actually polluted with null checks and safe calls and whatnot. So when you use Kotlin with Java libraries or server-side frameworks, the code is not nice. So it's a trade-off.
Exactly. It's a trade-off that we actually can see across the language, across the many languages and this subsystem. For example, a similar thing is with checked exceptions. While it would be safer to specify all the exceptions that can be thrown from your function, it's just impractical. And for example, in Java, you can see that sneaky throws functions, and sometimes people even copy the whole library just to turn checked exceptions into unchecked ones, because they don't want to check and write try catch blocks for every call site. And the same story is with nullability. It'd be actually safer to say that every function can return a null, but it's just impractical. And instead of solving your business task, you'll just writing nullability checks all over your code, and it'll be then harder to read and maintain this code.
Exactly. So regarding this very same example, if you consume this API from your Kotlin program, you see there is this foo method that might not return null. That's annotated with non-null annotation, and there is this other function called bar which might return null. And if we use that in Kotlin, we will see the compiler screaming at us in the second case, because it might return null. It's a nullable type that is expected from there. So you will see the compiler error actually in the editor, and you have to use the safe call operator to actually write code like this. Yes, so this is actually configurable. This is the default behavior, but you can switch it back to warning or even ignore if you really wish to, because it's not really part of the language. It's kind of configurable compiler option, right? So those are all the features we wanted to cover today. We do have a few questions that I have put aside to cover quickly after the session. Sorry, folks, if we did not answer all the questions I promised you, but well, we cannot spend the whole evening on the stream. But let's take some of them still to the stage. So, are there any Java interop risks or issues when a library is using those 2.1 features code from a Java class, or maybe from I'm adding from myself from some other Kotlin program that doesn't use those features?
No, no risk regarding calling it from a library, because all those features, they do not affect ABI, so they do not affect any binary metadata, because all those features tend to be used inside bodies of your function. So it's safe, and you can call them from a different library, from a different module, or from a Java. Usually, there might be a problem if, for example, the feature somehow interacts with the signature. But then in those cases, we mark signatures with a special metadata flag, and the compiler will issue a warning on call size.
Okay, then there is another one by Maya. I guess it's going to be quick. It's either yes or not. Soon or not soon. I guess the team will migrate to 2.1 soonish.
Yeah.
Right. We don't really. I don't know. Maybe you have an insight. I don't really know myself. Like, will it happen tomorrow or will it happen in a month?
It's going to happen. Maybe not tomorrow. I don't want to give promises, but it's going to happen soon.
Okay. Then there is a funny one regarding this string interpolation. Like, would we consider allowing doing something with other symbols rather than $? That's nice.
Yeah. So
but then we will like the problem. Well, first of all, like, why would you do this is already a bit arguable. But the problem with this is that the dollar has a very specific people brings this in that you're interpolating something, so that having more dollar it seems to be like good enough to bring this intuition into this, while at the same time not bringing like complex code which might be difficult to write. Like there are many other issues, like what do you allow, because I saw that you were using the pound symbol. Like, can you only use like monetary symbols? That would be a weird thing. But like if you suddenly allow things like capital A, then any capital A in your string will suddenly become interpolation. That's very hard. It's impossible to pick in a code review. So we kind of went with the smallest edition, what we thought was useful, which is just more dollars.
Right. So we give you the flexibility, but not too much flexibility, not to shoot yourself in the foot. This is a good one. I think we need to address regarding capped and KSP. What is the general advice here?
I'd say that if it's possible to move to KSP, then it's a way to go, because KSP is more lightweight mechanism, and it works better with IDE, incremental compilation, and so on. But still, we are committed to support KPT. So if you're on KPT, you can continue using it and don't bother with migration. But I'd say that
there are actually some improvements, if I remember correctly, about KPT compatibility in this version. We haven't talked about them, but they are on the release notes.
Yeah,
Right.
that's right. But I'd say that the overall recommendation right now is that if you want to start a new project and there is a KSP plugin, then it'd be easier to use KSP.
Okay. There were a few other comments regarding the well, I would say they are not really related to the language features, and therefore I will not bring them up to the stream. But I hope the community would help, or if you have very specific questions about using some tools or services or frameworks, we have a very good community in the Slack, and there are dedicated channels, and there are often people who know a lot about those specific areas of applications. So check out the Slack. With that, we are quite over time, and it makes sense for us to finish here. So thanks, Alejandro and Mikhail, for joining me today, and I hope everybody who are with us on the stream enjoyed it as much as I did. And thanks for coming, and have a nice Kotlin.